Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 6, Notes 5. Today we're talking about compound interest. This is our first lesson after the first Unit 6 quiz, so yeah, we're just talking about compound interest today. Compound interest is something that is kind of like exponential growth. It's equations that are growing, but the equation is a little bit different. There's a little bit of a twist to it. So up at the top of your notes page, we want to start with just filling in that formula. So there's the compound interest formula, and we're going to talk about what all those variables mean. It should look pretty similar to the exponential growth equation where we have that 1 plus inside parentheses, but there's this fraction here that means something different, and there's two variables up in the power instead of one variable being up in the power. So that's where this is going to get a little bit different. Okay. So let's just talk about all of the variables that are in that compound interest equation. Your variables look like this. A is your ending amount. A is like what your goal is or what you're trying to get to or what your balance will be. We also call that balance sometimes. P is the starting amount or the principal. That's where the P comes from. R is still our interest rate. And we still make that a decimal in case it was given to us as a percent. Most of the time they are given to us as a percent, just like they were in exponential growth and decay. And then n is the number of times compounded per year. That's what's going to be a little bit different today. You haven't seen n before. That one's a little bit different. And then t is the number of years. T is time. Okay, so a lot of those variables we've seen before, we can kind of recognize them. That n is a little bit different. So let's just talk about some values of n. If the question tells you that it is compounded daily, you need to think about how many days are there in a year. So compounded daily would be 365. That's your value of n that you would use. Compounded weekly, again, you need to think about how many weeks are there in 1 year. There's 52 weeks in 1 year. So compounded weekly would mean 52. Compounded monthly, how many months are there in 1 year? That would be 12. Compounded quarterly, how many quarters in 1 year? That's 4. Semi-annually, that means it's compounded twice per year, and annually just means it's compounded once per year. Now there's other options that may be used, but these are probably the most common ones that you'll see. So there's a lot of values that we have to put into this formula and simplify, and we're just going to do a bunch of examples together to try and make sense of what this formula looks like. So let's take a look at number 1. It says Maria's parents invest $14,000 at 6% interest per year compounded monthly. How much money will there be in 10 years? So what I like to go through and do first is figure out what all my variables are. I know that my starting amount is $14,000. So P is 14,000. And if you look at your list of variables that's right there, P, R, N, and T. A is what we're finding. A is typically the question. So we need P, we need R, we need N, and we need T. So R in this question, 6%, that means I need to make that a decimal. 0.06 is my R rate. And then N, this is the trickiest one because again, it's new for us to look at and it's not typically given in a number form in the question. We have to read the question to figure it out. So compounded monthly, monthly tells me that my N is 12 because there's 12 months in a year. And then how much money will there be in 10 years? So my time is 10. All right, so now let's put this into the formula. So my balance is going to be the 14,000. And then in parentheses, I open a parentheses, it's always 1 plus because this is always growing. Compound interest is always growing, so we're always increasing. It's always 1 plus. But then I have that little fraction, so I have R divided by N, 0.06 divided by N, which is 12. And then I close my parentheses, and up in the power, notice that you have two variables, N and T. That N is in your expression twice. So up there, I need N, which is 12, and again, and then T, which is 10. So that's what my formula looks like, okay? Now, setting up the formula is not so bad. The thing that people forget is they put the wrong value in the denominator. I see a lot of that. They always want to put the t. Don't put the t. It's the n. And then they forget to put the n up in the power. So that n goes in two places. You need to have n in two places. Make sure you watch for that. After you get it set up, this is really just going to become a lot of calculator work. How do I type this thing into my calculator? So you're going to want to get out your calculators and practice with me because we need to make sure that we're all doing this at the right time or like in the right spots. So the first thing that I like to do is figure out what this power is. 12 times 10. Figure out what that is. That's an easy one. So type that into your calculator, or 12 times 10 we can do in our heads probably. That's 120. I didn't do anything else with the equation. So that's 120. Okay, so now I need to work inside out. The next thing that I'm going to type into my calculator is this. So just take that into your calculator, do 0.06 divided by 12 and see what you get. I got 0.005. So that's A equals 14,000 times 1 plus 0.005. Now 0.005 is a pretty short decimal, but it's not always going to work out that way. You're going to be using the answer key on your calculator a lot today. That second answer, it's usually along the bottom row somewhere. On a graphing calculator, it's above the little negative sign. On a scientific calculator, let's see if I can find it. The second answer, yep, same thing, above the negative sign. So second and answer, you're going to be using that a lot today when I refer to that second answer key. That's what I'm talking about. That's something you can write down. So second, and then look for answer. Okay, you're going to use that a lot today. So with the 0.005, the next thing I need to do is I need to add those together. So all I'm going to do is just hit +1. I haven't cleared my calculator. I keep the 0.005 in there and I hit +1 and it looks like this. A is equal to 14,000, 1.005 raised to the 120. Then I take the power. So again, I'm not clearing my calculator. Don't clear your calculator. Leave that 1.005 on your screen. Hit the caret key and do the 120th power. So then you want a little caret key, 120th power. And you get 1.81939, and it keeps going on and on and on forever. Don't hit clear. Do not clear your calculator. Leave that decimal in there because now all you need to do is hit times and type in the 14,000. And I end up here with, so this was multiplication right there. I end up here with 225,471.55428. And this is money, so I'm going to round it to the nearest hundredths place. That means I look at the 4 to decide that one. So this is $25,471.55. Okay. So, moral of the story, you're going to do this in pieces in your calculator. A lot of people want to start left to right just because that's what we're used to doing. We're used to reading a book that way. We're used to reading equations that way. Notice that the multiplying by 14,000, that was the first thing in the formula, but that was the last thing I did in my calculator. So multiplying by 14,000 was what I did last. Keep that in mind. You have to take care of all of these parentheses first. You have to do powers before you do multiplication. We all know that. Parentheses come first, powers come before multiplication. I have to go in order of operations, even if it means I'm working backwards a little bit. Let's try it again. Determine the amount of investment of $300 is invested at an interest rate of 0.035%, or sorry, 3.5% compounded semi-annually for 22 years. This tells me my n is 2. So I can go through and write out my variables. My principal is 300. My interest rate as a decimal is 0.035. My n is equal to 2. That's what semi-annually means. And my time is 22 years. So let's set up that formula. My balance is going to be 300, open in parentheses, 1 plus, write in your fraction, 0.035 divided by 2. Close your fraction. In the power, you need that 2 again, and multiply by 22 for the time. So again, that n, that value of n is in two places. It's the denominator and it's up in the power. That's what I'm going to do first. 2 times 22. Most of the time we can do those in our head. But if you need to type it into your calculator, that's fine. So 1 plus 0.035 divided by 2. 2 times 22 is 44. All right. Next. Now I need to do the fraction. 0.035 divided by 2. So 0.035 divided by 2. I'm going to type that into my calculator. Do not hit clear. Keep it on the screen. So 301 plus, I got 0.0175 to the 44th power. Then I need to add, I'm still inside the parentheses. I haven't finished that yet. So then I need to add these two together. So all I'm going to do, since I left that 0.0175 on my calculator screen, I'm just going to hit +1. And I have 300 times 1.0175 to the 44th power. Then again, do not hit clear. You don't want to hit clear. The next thing I have to do is take the power. Powers come before multiplication, so I have to do this thing inside parentheses, raised to the 44th power. So with my answer, I'm going to leave my answer in my screen, just hit the caret key and type in 44th power, hit enter. So 300. And then inside now I have 2.14543 and so on and so forth. Now, very last thing is the first thing in the formula. So multiply by 300. I do the multiplication last, and I end up with 643.6290 and so on. Typically, compound interest is talking about money, so we're always rounding to the second decimal place. The 9 tells me to go up. That's $643.63. Don't forget to label your answer. I will mark it wrong if you don't label your answer, and we'll go from there. I highly encourage you, if you haven't been doing so far on numbers 1 and 2, to get out your calculator and try to set these things up with me, okay? Because I think it's going to be really important. I think typing these into the calculator is probably the hardest part. So let's take a look at number 3. Your allowance of $190 got an 11% compounded monthly for 1.5 years. What's it worth after 1.5 years? So principal, starting amount, 190 bucks. Interest rate, 11%, go back 2 places, that's 0.11. Compounded monthly. Monthly means our N is 12 and time is 1.5. All right, so let's set up our formula. We have $190, 1 plus 0.11 divided by monthly, which is 12, and then in the power, 12 times 1.5. And in 2 places, that's what your formula should look like. So I'm going to do this first. I need some lighter colors here. So 12 times 1.5. 190, 1 plus. I haven't done anything inside yet. 12 times 1.5 is 18. Okay. Next, I'm going to do the parentheses. Or I'm sorry, the fraction. Next, I'm going to do the fraction. Well, I got to go into the parentheses to get the fraction. So 190, 1 plus, here's where you type it in, 0.11 divided by 12, don't hit clear, just leave it. This is one of those long decimals, you don't want to round it off. That's the problem with this. If you hit clear and you round it off and you try to go only a couple decimal points off, first of all, anytime you raise things to powers, they change dramatically. They change very quickly. So if you are rounding things, you are losing a lot of accuracy. Every time you round, you lose accuracy. So 0.11 divided by 12, I'm just going to write out what it is to start, 0.00916, and it goes on from there to the 18th power. Again, I did not hit clear on my calculator. I'm just going to hit +1. So I have A is equal to 190, 1.00916, on and on, raised to the 18th power. Do the power next. Don't multiply, do the power next. Caret key, so leave that in your screen, hit the caret key to the 18th power. A is equal to 190. That's 1.1785 and so on. I'm going to leave it like that. Don't hit clear, just hit times 190. So I end up with, ooh, not a 1, sorry, 2A equals 223.91632. And it goes on. 6 tells my 1 to go up, so that's $223.92. Hopefully this is working for you on your calculator. We're going to do a few more practice questions together. Number 4, $440 gets 5.8% compounded annually for 8 years. What will your $440 be worth in 8 years? So, principal, 440. Interest rate, 0.058, because I got to go back 2 places. N, compounded annually. Annually just means that it's compounded once. So N is 1, and then time is 8 years. So here's our formula. A equals, oh, sorry, I didn't put my 0 there, duh. A equals $440, 1 plus 0.058 divided by 1 raised to the 1 times 8 power. All right, do this first, obviously. 1 times 8 is easy. $440, 1 plus 0.058 divided by 1 raised to the 8th power. Then do fraction. $440, 1 plus 0.058 divided by 1. You can go ahead and type that into your calculator if you want to, but you don't need to, because 0.58 divided by 1 is just 0.058. 0.058 divided by 1 is what I meant to say. Okay, so I want you to take a look at this for a second. Notice that we're compounding annually here. So my n was equal to 1. If you take a look at this formula right here is really just the exponential growth formula. That is the same thing. That, oh, that's an O, growth. That's what happens when you're compounding annually. If you're compounding annually, really all it is just the exponential growth. So we started with the compound interest formula, but really it's just an exponential growth equation. That's all it is. So if I finish this off, I need to add those two together. 1 plus 0.058, 440, 1.058, raise it to the 8th power, caret key, powers come next, multiply by the 440 last, very last thing. That gave me, once I raised it to the 8th power, I'll just write out the start of the decimal. Don't clear your calculator. 9482 and so on. And then, very last thing, multiply by 440. So I end up here with 690.77723 and so on. So 690.78 is kind of what I'm looking at. All right. Let's take a look at number 5. We have 2 more questions left. Your $54,200 2-year car loan is at 15.1% compounded daily. Holy buckets. What will you have paid for your car after 2 years? Oh boy. This is kind of a sad one because this is a car loan. This is about how much we're going to have to pay. That's no fun. So 54,200 is my principal. My interest rate is 0.151. That's a very high interest rate for a car loan, just so you know, FYI. Very high interest rate for a car loan. Compounded daily, wow, daily, 365. And then time, 2 years. So here's our equation. $54,200. 1 plus 0.151 divided by 365. And then in the power, 365 multiplied by 2. Do that first. Figure out that power, 365 times 2, because you can do that separately from all the rest of this garbage in here. 54,200, 1 plus 0.151 over 365. 365 times 2, it's 730. And then next, next, we're going to take care of that fraction. You're going to get a funny answer here for that fraction, and we'll talk about that. So 54,200, 1 plus 0.151 divided by 365. You likely have something that has an E written in your calculator, depending on what your calculator looks like. My calculator looks like this, 4.1369, and then it says E and -4. If you remember back to the scientific notation lesson that we did at the very beginning of this unit, this E just means times 10 and then raised to that power. So what that means is I need to move my decimal point back 4 places, and then I'd have 3 zeros in front. And that just comes from scientific notation. So 0.000413 and so on. Raise the 730th power. Oops, sorry, that's 730, not 770. And it really doesn't make a big difference because all I'm going to do is hit +1. Just leave that answer, even if it's in scientific notation, leave that answer in your calculator and hit +1. And it puts it back into a decimal for you. So this is 54,200 and then 1.000413 and so on. Raise it to the 730th power. That's a big power. That's exactly the reason that we don't clear our calculator and we don't round, because this is a very large power. And if you cut your decimal off at any point, raising it to the 730th power is going to make a very big difference when you start to multiply and things like that. So 54,200, I end up with 1.3524 after I take that power, then multiply. And I get 73,304.24. Sorry, my zero didn't close there. 2404, and I assume it's going to go on from there. So think about this car loan. So you bought a $54,200 car. This is an expensive car. You bought a nice car, whatever it is. By the end of the 2 years, you're going to have paid $73,000 for that car. That was an expensive car loan. That's a lesson in loans for you right there. So 73,304.24. That's your dollar amount. Ouch. That was a pricey car. It was a pricey car to begin with. And now it's even more of a pricey car. Holy cow. Okay, number 6, last one. Your 16-year investment of $40,000 at 14% compounded weekly. So 14% compounded weekly is worth how much now? So let's take a look at our variables. My principal, oh, I should get out of white. There we go. My principal is $40,000. That's my starting amount. My interest rate, 14%, that's 0.14 if I move it back 2 places. My N, compounded weekly, means my N is 52. And the time, 16-year investment, so 16. If I set up that equation, it looks like this. 40,000, 1 plus 0.14. Oops, I almost forgot to make that a fraction. Try again. 1 plus 0.14 over 52. There we go. And then 52 times 16 up in the power. So 40,000. 52 times 16 is going to be the first thing that I take care of because I want to see what that is. And I get 832. So 1 plus 0.14 over 52 to the 832 power. Now do the fraction because I got to go inside the parentheses next. And inside the parentheses, I got to do division before I do addition because division comes first. So 0.14 divided by 52, that's 0.00269. And so on, it keeps going to the 832 power. Don't clear your calculator, hit +1. I have A is equal to 40,000, 1.00269, and so on to the 832 power. Raise it to that power. 40,000. And now inside I have 9.365 and so on. Now multiply, very last thing, times 40,000. I get 604.0011. So in terms of money, second decimal place, 1 tells me stay the same. I'm really at 00 there. $374,604. I don't need to worry about the cents because it was 00 after that. And there we have it. That takes us to the end of our notes video. So compound interest, it's a big long equation. It's a lot of calculations in your calculator. Make sure you're doing them in the right order. Don't hit clear, use that answer button, and we'll go from there. Thanks for listening. Check off your notes sheet with Ms. Johnson, and I'll see you later.